In this lesson, we're going to talk about logarithmic functions. The logarithm is the inverse of the exponential function, similar to how dividing is the inverse to multiplying. Right? So, like for example, say you want to divide 56 by 7, you would ask yourself, what do I multiply by 7 to get 56? Right? So 7 times 8 would give you 56. So that means that 56 divided by 7 is 8. So we're going to do something similar for logarithms, right? So when we're trying to figure out a log, usually what we're going to do is to think of it in terms of exponents. So we want to be able to go back and forth between the log form, which looks like this, and the exponential form, which looks like this. So let's break down the different parts of logarithms and exponents, right? So in exponential form, the number here at the bottom is called the base. The number up here is called the exponent. And when you raise b to the y power and obtain x, x is the result of that calculation. Okay, so these three parts of the exponential form are in the log form, but in different locations, right? So the base goes here, the exponent is here, and this is the result. So the way you would read this is log base b of x is equal to y. So when you think of the log, you should think of it as this number raised to this power results in this thing. So typically, if we want to be able to calculate a log and get y, you should ask yourself what power does b have to be raised to obtain x? So for example here, if I want to calculate log base b of 1, so what power do I have to raise b to obtain 1? Well, the rule is that anything to the 0 power is equal to 1, right? So no matter what the base is, the log of 1 is always going to be equal to 0. And another property you can remember is log base b of b, right? So again, you can, if I want to calculate this, what should I raise b to obtain b? Well, anything to the first power is itself, right? So that means that log of b is always equal to 1 for any base. When the base and this number matches together, it's always equal to 1. So there are two special logarithms that we're going to see a lot. So there are the common logarithm and the natural logarithm. So the common logarithm is just written log without any base. So if there's no base, that means that the base is equal to 10. And so the common logarithm means that the base is 10. And for the natural logarithm, it's written as ln of x. Again, there's no number here written here as the base, but it's understood that the base is the natural number e. Right, so this is the natural number. So we're going to work a lot with the natural log and base e, so you should be familiar with where these functions are located in the calculator. So on this graphing calculator, right, so I have, this is the common logarithm, this is the natural log, and if you want to exponentiate with the natural number, there's e to the x here, or there's also e here, right? So big log So as we said before, log of 1 is always equal to 0, right? So you can see natural log of 1 is equal to 0. Common log of 1 is also equal to 0. So you should be familiar with using these operations. Okay, so in example 1 and 2 at the bottom of the page here, basically we want to become familiar with going back and forth between log form and exponential form, and where all of the pieces go. Okay, so example 1, we're given expressions in log form and we want to write the exponential form, right? So we just identify the base, the exponent, and the result, right? So in exponential form, the base goes here, the exponent goes here, and the result goes after the equal sign. So we just follow this, right? So here, log, when the base is not written, that means that it's base 10. This is the exponent, and this is the result. So that means that in exponential form, you have 10 raised to the exponent, which is t, is equal to z. Right, so here we're just switching to exponential form. We're not calculating anything. Similarly, natural log, so that means that the base is e. This is the exponent, and this is the result. So I can write the base is e raised to the exponent, which is x, is equal to the result, which is 6. So again, we're not calculating anything. We're just writing it in exponential form. Okay. So in example 2, we go in the other direction, right? So we identify the base, the exponent, and the result, and we put it into log form. So this is the base, this is the exponent, and this is the result. So writing it out, it's log of the base, which is m, and then the result goes with the log, right? So that's n, is equal to the exponent, which is -7. And then here, this is the base is e, so we should use the natural log, exponent, and result. So again, base is e, so we use the natural log. What goes with the natural log is the result, so we have ln of y, and it's equal to the exponent, which is x. And then we can check our answers at the bottom here.